All right, folks, it's Bass Action, back in action here. We are jumping into a brand new chapter, and we're going to be learning about matrices in this chapter. These might be brand new for a lot of you. Maybe you've taken the SAT or the ACT and you've seen some questions and didn't really even know what the heck they were talking about. So we're going to cover some basics of our matrices in this chapter. On this page, we are just going to start with some very, very basic vocabulary and adding and subtracting our matrices. So let's start with the definition up here on the top. A matrix is a rectangular array of real numbers. Okay. Now, different books use different words. Some books will call it a dimension, and some books will call it an order, but it's a description of how big our matrix is. And when we talk about its dimension and order, we describe the number of rows by the number of columns. And this next little note here, we actually don't need this. We're going to cover multiplying matrices later, so you can just scribble that out. I'll talk about it in another video later. The next thing that we've got are equal matrices. In order for two matrices to be equal, the matrices need to have the same order and have the same corresponding entries. So they really just need to be identical matrices and not just the same size. Now, an additive identity matrix, okay, so just a little vocabulary here. An additive identity matrix does not change, that's our first blank here, does not change an original matrix when added. So when we think just about addition in general, what number can we add to another number without changing its value? And that number would be 0. So our additive identity matrix is also called the 0 matrix. So just a little vocabulary there. Now let's jump into some examples. All right. If we want to talk about the order for each matrix, remember, order is written rows by columns. So what we would do is we'd count how many rows, and we'd say, oh, we have 2. And then we use a little X, so like we would read that by, and then we'd say how many columns, and we'd say, oh, we have 2 across. So we'd say this is a 2 by 2 matrix. On our next one, we would say that we have 1 row and we have 3 columns. On the next, we would count our rows and we'd say we have 3 rows and we have 2 columns. And on our last one, we have 2 columns and 2 rows and we have 3 columns. Okay. The order or dimension, some books will call it the dimension. That's an important idea. It's going to impact us when we're trying to add. It's also going to significantly impact us when we are multiplying later. Up above, I talked about the additive identity matrix. So here's a sample 0 matrix. Just all the values in it are 0. So if we wanted to write a 4 by 3 0 matrix, remember the 4 is going to be our number of rows, and our 3 will be our number of columns. So our 4 by 3 0 matrix, we should have 4 rows of zeros. So I'm going to say 1, 2, 3, 4, and then I need 3 columns that look just like that. 1, 2, 3, 4, 1, 2, 3, 4, and then we usually put these little brackets around it for our matrix notation. All right, now jumping into some addition and subtraction on our first 2 examples here. The important thing to know that when we are adding and subtracting our matrices is that they need to have the exact same dimensions, the exact same order. So this is a 2 by 2 and this is a 2 by 2, so we could add those. Adding matrices is really, really simple. All we have to do is add each of the corresponding values. So for example, if I want to do A plus B, I'm going to add a 2 and a -3. So I'd say 2 plus a -3 is a -1. And then I would do 4 plus 0, and that would be 4. And then I would do -1 plus 5, and that would be a 4. And lastly, I would do 3 plus 6 would be 9, and I'd put my brackets around that. If I wanted to subtract, same idea. I'm just going to subtract each of the components. So I could do 2 minus a -3, and that's going to give me a 5. 4 minus 0 is still 4. Negative 1 minus 5 is a negative 6. And 3 minus 6 is a negative 3. So pretty simple there. The next thing that we're going to do is called scalar multiplication. So this 3 times b means that I need to take a 3 and multiply every element inside that matrix by a 3. And I'm going to eventually subtract the 2 times a. So I'm going to take a 2 and I'm going to multiply each element in there times 2. So when I do these, I like to kind of just organize myself first. So the first thing I'm going to do is I'm going to write out what 3b would be. So I would have a negative 9, I would have a 0, I'd have a 15, and I'd have an 18. And then I'd write out what 2a is. Just makes this all a little bit easier. So I'll have a 4 and an 8 and a negative 2 and a 6. And then I can just go ahead and start subtracting each of the elements. So negative 9 minus 4 and 0 minus 8, 15 minus a negative 2, and 18 minus 6. So as I go through that process, our negative 9 minus 4 is going to be a negative 13, 0 minus 8, 15 minus a negative 2. Remember, that's going to flip to addition, so I'll have a 17, and 18 minus 6 is 12. So that would be my final matrix on that. As you turn the page, we're going to start to investigate and learn things that we can do with our matrices.